O Levels Maths Exercise 13A D1 7th edition. We shall try to cover question number 9 then question number 10 in this video. Question number 9 is, this is the figure which is given. This is a four-sided figure which is shaded. We have to take out the area of the, we have to calculate the area of this four-sided figure. A four-sided figure in maths is called a quadrilateral, but this rectangle, it has nothing to do with this quadrilateral. We do not have to find the area of this rectangle, but this rectangle is here to help us find the dimensions of different sides of this quadrilateral. Hence we shall proceed with the question. In the figure, AD is equal to 23. This AD is equal to 23. If this is 23, a line opposite to it is also 23, which means this line is also 23 and this line is also 23. Now dp is equal to 7 meter. dp, this line from the, now they have given us the dimension of this rectangle, a part of it. This d from d to p is 7 meters long, and from B to R is 13.5 centimeter. They have given us the dimensions of this outer bigger rectangle, but we have to find out the area of this quadrilateral. I am calling this bigger a rectangle and this a quadrilateral because a rectangle is a regular quadrilateral which has a name. This inner quadrilateral does not have a name. It is not a square, not a rectangle, not a rhombus, not a kite. Hence it is called quadrilateral, just quadrilateral, and this, the outer quadrilateral, is a rectangle. If P is directly above R, if P is directly above R, which means that it is a straight line, and which also means that if dp is 7 meter, then AR is also 7 meter. It is not slanting, it is a straight line, which means these two sides are equal. And these two sides are equal because P is directly above R. Find the area of the shaded region. We have to find the area of the shaded region. Now this is an irregular quadrilateral. It is not a square, not a parallelogram, nothing, but it is of some other shape. Now I have to use the inferences which have been given to me to solve my question. Now they have drawn this line which is also a diagonal of this quadrilateral. A diagonal joins two opposite sides of any quadrilateral, any square, rectangle, or anything which is in which has four sides. So it is a diagonal which is joining. This diagonal has divided this quadrilateral into two triangles. If I can find the area of this triangle and find the area of this triangle and then add them, then I can find the area of this quadrilateral. Now I know that this is also, this line is 23 because it is opposite this line which is 23. So this line, dotted line, is also 23. Now for area of a triangle, I need two things: base and height. Base and height are two things which are found at a right angle triangle. If this would have been the part of a quadrilateral, then 7 would have been the height. Now it's not a right angle. These two are not right angle triangle because these marks are not here. So there are no right angles. So what am I going to do in such a case when there are such triangles, such triangles which do not have a right angle triangle, then height is just remember that height is never slant, it is straight. This line is slanting, all these lines are slanting, and there is no right angle triangle at any of them. So height is always straight. In such cases, when the triangle is of this shape, the height is drawn starts from this apex of the triangle, the two lines which are joining the highest point of a triangle, and it is drawn and it touches the base, and here it makes a 90-degree angle. So what am I going to do? I am going to rotate my triangle like this. If I'll take this triangle, because I know the base, I don't know any other dimension. This straight line is, as it is opposite this line, I can draw the height. I have given the height, which is, as this side is against this height, hence it is 7 meter. This will become the height, of this triangle. So I base is 23 and height is 7 meter. Likewise, I will rotate my quadrilateral like this, and here I shall draw the height. In such triangles, the height starts from the apex of the triangle and touches the base. I am making this diagonal a base because I know its dimension. Now I also know this straight line because it is opposite this straight line, which has a right angle over here, which is 13.5. Hence I know the height and base of both the triangles. First I will solve the triangle. I will say, in triangle RQP, I am taking this RQP, I am taking this triangle. For this triangle, I have triangle RQP, base is equal to 23, because I am taking this line as base. I have rotated this triangle, and height I have drawn from here to here. It's a straight line which is 7 meters long. So base and height is equal to 7 meters. Since its area is equal to area of a triangle is equal 1/2 into base into height is equal to 1/2 into 23 into 7, which is equal to 80.5 meter square, is the area of this triangle RQP. Now in triangle PSR, now I will take this triangle. In triangle, I will write it down. In triangle PSR, base is same, which is 23, and height is equal to 13.5. I am solving this question in this manner because I am going to use the information which they have given, and it is the only way in which we can use the information to our benefit. Hence I am solving it like this, by dividing it into two triangles. Now here, this is the base which I have taken. This 23 is the base, and height, which is from here to this point, it will make a right angle here. It is opposed to this side, which is 13.5 meter, hence height is 13.5 meter. Hence area is equal to 1/2 into 23 into 13.5, which is equal to 155.25 meters square. Now in this I have found the area of this triangle and this triangle. Now if I will add them together, then can have the area of the quadrilateral. Hence area of quadrilateral is equal to, I am going to just add these two, 20.5 plus 155.25, which is equivalent to 235.75 meters square. Now question 10. In question 10 we are given this shape and we have, which is of a triangle. There are two triangles in this shape. One, this big triangle in which consists of a small triangle. There are two triangles in it, and this is not a triangle because it has four sides. It would rather be a quadrilateral than a triangle, but it can be solved through triangles. Now this is a big triangle and this is a small triangle. They are asking to find the area of the shaded region. How can I achieve this? I will calculate the area of the big triangle and subtract the area of the small triangle from it, and I shall get the area of the shaded region. So what is this? What is the question? In the figure, AB is equal to this dimension 20 meter, BC is equal to 21, AD is equal to 10, AD is 10, and DE is equal to DA is 10.5. Find the area of the shaded region. So I shall calculate area of triangle, area of big triangle is equal to 1 by 2 into base into height is equal to 1 by 2 into base. The base here is in the big triangle, here is this sign which is suggestive that it is a 90-degree angle. Hence this is perpendicular, which is height, and this is base. So I will use them. 20 is the base and height is 21. When I shall calculate them, I shall get the answer to 110 meters square. Now area of small triangle is equal to 1 by 2 into base into height. Now I see if I can consider this triangle only. I have to notice where is this sign which suggests that there is a right angle triangle over there. So here is a sign which is suggestive that it's a 90-degree angle. Hence one of it is base. These two sides will constitute base and height. Either one is you can it's your choice, because these two can be, one of them can be height and one of them can be base. This is not the base of this triangle because the 90-degree angle is here. Hence I shall take base as 10, 1 by 2 into 10, and height as this one, 10.5 to 5 are 10. This is equivalent to 52.5 meters square. Now area of shaded region is equal to, how am I going to calculate the area of the shaded region? I have calculated the area of the big triangle and the area of the small triangle. From the big triangle I will remove the area of the small triangle and I will get the area of the shaded region. So hence area of the big triangle is 210 and small triangle is 52.5. After subtraction I get the result which is 157.5 meters square. Hence, this is your answer.